To access the Open Weather API, we simply are going to have a long URL that we put into it that we will get to in a moment. But before we do that, we need to have a little explanation of some of what is going on with this. So at the beginning, we got some CSS. You can stylize yours however you want. Currently, the artwork and everything that we're going to be building towards this will be written onto the canvas. Has an ID of canvas 1. It's currently set at 900 by 200 pixels in size. So that should match some of the artwork that you were asked to make. If you change the canvas, change your artwork, all is good. My feelings don't get hurt. .weather is the paragraph where some text is showing up so that we can see that in our document. We can see some text is showing up over here. We can see we have date and time. We got some undefined things that we're going to make sense out of in a little bit. We have some other things that are occurring on the side over here, and then our canvas, which has some grid lines being drawn into it, and we'll be using that as a way to understand how we're positioning some things on this canvas. So the canvas is broken into a 10 by 10 grid, but because it's not square, that's why they're funny looking rectangles. Through a lot of this document, I use let instead of using const in most cases, just in the interest of expediency. I think it's also because after so many years of typing var for everything in JavaScript, using const and let and having to use two things and think about it versus typing one thing and going on with my day. So I did use let for a lot of things because, well, it works. I need to go back and clean it up and switch things more to const because most of these would work just fine as a constant variable instead of a let variable, but it is what it is. It works for now. It's just not as pretty as I would prefer. So moving forward with this, what we are doing to access the Open Weather Map API is we have to make a request of their server. Their server is going to then send us back a JSON file. We take that JSON file and then we have to parse it. We have to try and make sense out of it and understand it so that we can use it. The good part is JSON is JavaScript. So when you're working with JSON files in other programming languages, then you have to take that JSON and convert it into a form that that language can understand, which makes it kind of annoying. But because JSON is JavaScript, it's JavaScript object notation, if you get a JSON file, it's super easy to start using it. As you're going to see tonight, we're going to just look at the JSON and go, OK, I want to know what temperature is. Boom, done. I want to know the wind speed. Done. I want to know my location. I want to know what kind of weather I'm experiencing. Done. It's all right there, easy to find, easy to access. So that's what we're going to do. So what we do is to access a JSON file, it requires us to do a couple of different steps. We have to create what is commonly called an HXR file. That HXR stands for XML HTTP request. HXR is just easier to say. So we can see X from XML, H from HTTP, and R from request. So what we're doing is we're making a request for this XML file. We're going to then tell that HXR object to connect to the server using its open method. So we say HXR open, and then we specify how we want to do it, and we do it by saying we want to get something, and then we're specifying where we want to get it from, and then we put in true as our final parameter. Now you will notice something in this particular string for where we're getting it from. I did not use single quotes, but used backticks. The backticks allow me to embed a variable object into my string. I could use single quotes and a plus sign to piece it together with a bunch of pieces. So I would say HTTP open weather map data 2.5 weather lat long blah 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 app ID equals end quote plus API key plus open quote ampersand units equals imperial quotes. I could do that. If you get used to using the backtick, I think you'll find that it's less messy because you don't have all these pieces connected with pluses. It just is easier to follow. If you don't like it, you can go back and do it the other way, and again, my feelings don't get hurt. I will, through this document, be using some of each depending on what I'm doing when I'm putting strings with variables together. And in your own documents, you can do what you want. But I want you to be exposed to both. We've used the other method extensively so far in the term. Now we're looking at this newer method. This is part of modern JavaScript. And a lot of documents that you're going to find, examples that you will find and have to modify and work with, are going to use some of each. Most people don't use just one or the other method in their documents because anyone who's been writing for a while is used to stringing things together with the plus sign. Now that you can use backticks, you do, but sometimes in the throes of high-speed coding where you're just spitting a bunch of stuff out because your brain's on fire, you don't always remember to use the new method. You go back to what you've done because your brain is already on to the next line of code while your fingers are still typing. So you end up going back and forth while you're doing things, and that's just part of it. So we create the HXR object. Then we use the open command where we say where we're getting it from. And then we have to set the data type of how we want it to be interpreted. When that data comes back, we want it to be text. That's the cool part about JavaScript is when things are in text, it can understand them as code. It doesn't freak out about that. Like some languages, if you said, oh, it's text, it's like, well, it's just string, it's letters. And then you have to somehow convert it, and it's a lot of extra heavy lifting. JavaScript's really friendly about that. So then we set the response type. And then finally what we're going to do is we can't use that information until it's loaded. So we're going to attach to it, and a common way of doing it, instead of writing an event listener, another way of writing things is using, so we could use hxr.addEventListenerLoad and then call a function, or we can use the hxr.onload, and then we can say equal to event and then use the arrow function designation, which we've seen that as we did our work in jQuery. And then we put a bunch of stuff in there. And that stuff, when we're looking at it, we say if hxr status is equal to 200. 200 is success. Anything that's not 200 means it failed. So if we fail when we try and connect to the server, then it's going to fail. It doesn't mean our JavaScript breaks, it just means it fails. And then what it's going to do at the end on our if statement is it's going to print out the error code where it's going to say error code plus hxr status. Now you'll notice here I'm stringing a variable together with text using the plus sign instead of using the backticks. Again, doing both. Both methods in the same thing, but you can see on the lines above this, there's all kinds of examples of using backticks because these were easier to write using backticks than it would have been using the strings with pluses. So that's why it goes back and forth between them. Okay. So if we succeed, gives us a code of 200. If we fail, it's going to tell us what the fail is. So I am going to break mine temporarily here. And see what happens. And we'll see it shows up error code 202. I have no idea what that error code means, but if I went into the API documentation, I could look up error codes. It would tell me what that error code was. So it's always good to be checking for that in your documents and while you're working. Okay, so 502 bad gateway. I can see now in the it logged out the message with more detail there in the console. So that's telling me it really didn't like that path that I just asked it to follow as part of making it work. So HXRs are how we process JSON and make the JSON usable. Because when the JSON is in its own document, and we can have a separate JSON file that we work with. So when we have a JSON file, like let's see here, I look at this. This is a JSON file for loading images. So we can see how it's organized. So I have a series of frames. Each one of these frames references a different image file that are all part of a larger texture atlas. So the texture atlas looks like this. So I have a bunch of images that are all in one single PNG file. So all I do is load one file, but then I need a way to parse that file or to make sense out of it. Well, the program that put all those pictures into one file also created a JSON file which tells me where an image is on that larger document, how big it is, and has it been trimmed or rotated, so then I can use that information to put it into my project. We get undefined showing in JavaScript because that means it does not have a value for that item that we're asking it to show. JavaScript is a pretty friendly language unless there are some ways we can coax it into a strict form where then if it doesn't find something, it crashes or gives an error message instead of going, whatever, it's undefined, I don't care, and it moves on, which is what JavaScript has been known for. So a lot of programmers have hated JavaScript for that. I think it's kind of nice sometimes. But then when you get undefined and your program doesn't crash, but it's not doing what it's supposed to, then you wish it would have crashed so you could find where it was stuck. So it is what it is. So what we're going to do here is we have a couple values that we need to figure out how to populate. Now, I logged a couple messages out. I logged out JSON data loaded into object, and then I logged out the weather. Now what I want to know is the name of the location that is showing up. I want to know what the current temperature is, and I want to know what the current wind speed is. Because you will see that date and time are working, and we'll talk about those in a little bit because we need to modify that because that's giving us the actual time on the computer. But I want to know the date and time of the weather information. So when this weather was gathered, I want to know what time that was. So we're going to take a look at that. So the first thing that we're going to do is look for the location. Well, I've logged out this weather object. So we have an empty weather object that we're populating where we say weather is going to be equal to JSON parse and then the response text that came back from this HXR request. So the text that came back, we're going to then load into this weather object. And we use the JSON parsing module. And when we do that, we can then log out and see what that weather is. So in my browser, if I click over here, I will see that there's some information that is now showing up on screen. So I can see where it says base, clouds, coordinates, DT, ID, main. If I look under main, we get, look at, there's some temp information. I can see a city name. Well, that's the name that I'm looking for, and I want to populate into my location. So if I want to populate that name into my location, I'm trying to figure out how to understand this JSON object that has been provided. Back to the Open Weather Map API, I will see in the information that comes back, I can see how it's organized. Now, under this, if I want to know that name, that location of where we've landed, we can see there's name. So we have top level parameters that get returned. Coordinate is one, and then it has key value pairs within that for latitude and longitude. Then we have a weather object that comes back. Then we have base, then main. So the listing here in the API is not necessarily line by line matching the listing as it shows up after we've parsed our JSON. So here I am back in the Open Weather API. I think this is a little bit easier to see kind of how things are grouped when we can see under coordinate, lat, and long. Weather has ID, main, description, icon. Main has temp and pressure, humidity, min, max. Now, not every piece of data comes back from every weather station. So when you make a request, it's entirely possible that a piece of information that you were hoping to come back that's on this list, it may not be there. So if you're not asking for one of the main ones, you might not get it. So like sea level, it doesn't always come back. Ground level, maybe. So sometimes you get these. It depends on what station and what data it's feeding out. So we do have to be aware of that we don't always see all those points of value coming back. Snow. I didn't see any snow listed on the data that came back. Now, it's warm out. It's not snowing. Well, it's not warm, but it's above freezing. And it's not snowing. So we don't necessarily see that because I don't see any snow. Let's see, rain. System, yeah, so see there's no snow. So if I'm asking for something, I may not get it back. Under main, humidity, pressure, temp, min, max. Keep going to the wrong thing. But under main here, I can see sea level and ground level. Well, those didn't show up. So don't count on everything being there every time. So if you get some really cool ideas on like, well, I want to plot it based on our elevation above sea level. Well, maybe. But not always. Some places will give it to you, some won't. But we are looking for some basic things. We want to know the name of where we are. We want to know our wind speed. We want to know our temperature. Eventually, we're going to want to know the type of weather that's going on. So we're going to look for those pieces of information. Going back into the code, we can see here's our temperature. So we have to figure out how do we get that value out? How do we get our location name out? Well, the way we do it is we access it as an object inside this data that we've asked for. Our data object is called weather. Now, inside of weather, we can go and look for the location of where we are. As I look for that location, weather is my object. And now going back into the API, one of the top level things I can find is name. So I'm going to try that. I'll say weather dot name. Now I'm going to get rid of that equal so it doesn't cause an error message. I'm going to save this. And now if I go back into my document, we'll see I now have a name there. And that name is showing up in the string because this string, I say, print out the location, the temperature, the wind speed, and my time. And on the next line, then I put out my time string, which we'll talk about that in a little bit and why it had to have that much junk as part of it. So I'm able to get the name of my weather. So now if I want to get the temperature, it's going to start out and I'll say weather dot. And then I just have to go and look through either my JSON object that came out here to find it, or I can go back into the API, go, okay, temperature is under main. And then under main, I can go and find, it'll be temp. Okay, well, that should be easy. Let's also verify we have main here. Open up main, there's my temp. So if I want that, weather main.temp. Save that and see what loads. And we can see it loaded. I get 40.75 degrees. Now, if I want to round it so I don't have decimals, if I just want it to give me whole number of degrees, then I can apply some formatting to this value. So I can format this value using JavaScript's math function. I know math is an evil word, but I like it. And it shouldn't be a terrorizing word or a trigger term, though I know for some people math is a trigger topic. But we can just say math.round, and inside the parentheses the number that we're rounding, which is weather.main.temp. And when I do that and save this, now if I go back to my document, I'll see it just says 41 degrees. To show up, I'll just say math.round weather.wind.speed, and that's going to give me my wind speed. Now, if I want to put a space between my wind speed and miles per hour, I can put a space on that line, save this, go back, load my page. Now we can see where it says Osseo 41 degrees, wind 13 miles an hour. I do have to point something out that I didn't mention before is after we create the HXR object, so we create the XR object, we specify where it's going to get data from, we specify the response type, we specify what we want to have happen after the HXR data is loaded. Now it is important that we don't try and do anything with the data until it's been loaded. Otherwise we will get error messages, because if the server is trying to send us data and we're already trying to use the data before we know the data, then it will break. But after onload, at the very end, you'll see that there's a statement where it says HXR send. It's not until that line is encountered that it makes the request of the server. So we will take advantage of that as we build more complex structures, so that if we're trying to load image assets and then load JSON assets, and then finally, after we know all of those are loaded, then we can go ahead and go do something else. And that's why there is this little line in here I haven't talked about, plot, where inside the successful conditional statement, so inside where it's successful, if status code is 200, that means it was successful. The very end, after it put the text on screen, it then calls the plot function. The plot function is where it's going to then plot all of our graphics, images, and other things onto the canvas object. And that is where we will be moving to next. So we've now learned how to connect to the OpenWeatherMap server, use the API, request and receive a JSON object, parse that JSON, and do something with that information so we can grab that data and display things on screen. Now we're going to use more bits of that data. We'll look at the sunrise and sunset and the current time and start exploring how we can actually play with that a little bit further. Now, one other point on the time here that is relevant is if we look at what's happening, it says let time equals new date. Not new time, new date. And what that does is then that gives us a date object. Now, what is going to happen is when we get the date and time object from OpenWeatherMap, it's not going to give it to us in a kind of human-friendly format. It gives us in the number of seconds that have passed since 1970. Computers register time. So if we ask the computer what time is it, it generates a time value based on how many seconds have passed since the year 1970. Or JavaScript prefers to actually use how many seconds have passed since, or how many milliseconds or thousandths of a second have passed since 1970. The time that comes back from OpenWeatherMap is measured in seconds, not in milliseconds. JavaScript uses milliseconds. So we do have to do a little bit of conversion to go along with it. So if I look at the file here, weather0 that I have, when it loads in the browser, we can see that it is now showing me a day and time when I say show me that time. It's not showing me those milliseconds. So it converts that value to a usable number. JavaScript also has methods built into it, so I can say time get hours and get minutes, and it gets those values back for me. But this is not giving me the date and time of when I retrieved my weather. This is now giving me the date and time of when the weather data was last recorded. So if we look at that, we can see that it's at 1851, or was 1854 and 31 seconds. Now if I ask for that time, and the time is marked with DT, And we have to take this. Now if I save this and run it, we will see that if I just say give me DT, it comes out as January 18th. So we've had exactly enough seconds pass between January 1st and January 18th in the year 1970 to happen. But it's not 1970. It's a little bit later than that. So we have to take and multiply that value by 1,000. And then that will get us to today's time of 1851. But if I look at the clock, I can see that it's actually 1855. So this timestamp that came with my weather data is a couple minutes behind the current date and time. The next bit of gobbledygook that is happening here, we can see that we have to do a little bit of formatting, because if certain times as they're provided, if I don't do this formatting of minutes, so if I don't format, I'm just going to comment that out. And now if I say minutes, I'm just going to do, say instead of that, I'm going to say 5. Now if I look at the time, we'll see that it's 6:5. When if it's 5 minutes, it should be 6:05. That would make more sense for a representation. So we need to convince JavaScript to show us time when time is less than 10. So it'd be 0, 1, or 0 through 9. We need to add an extra 0 in front of the minutes value. When I do that, we'll now see 0.5 occurring. And that makes more sense as part of it. Now, if time isn't less than 10, then we need to go and figure out how can we represent it a little bit differently, because if I get rid of this modification there, and now let's just get this stuff out. Oh, got rid of too many things there. Well, see that the computer is telling us the time is 1851 or 6:51 if we're PM, if we're using AM PM. So it gives us time measured in a 24-hour or military time, not in the kind of 1 through 12 hour with AM and PM on it. So if we want that formatting, then we have to do a little bit of calculation. That's what these next lines do. So if the hours are 12, then it says it's going to be 12 plus the minutes and then append it with PM. If the hours are greater than 12, it's going to be the hours minus 12, because if the hour is 13, or in this case the hour is 18, 18 minus 12, that gives me 6, and then whatever the minutes are plus PM. So we can see that that's indeed happening. I get the 6:51. And if the hours are 0, then we want it to be 12 plus the minutes in AM. And if the hours, the only other option would be their hours are indeed going to be kind of 0 through, or 1 through 11. And then that would be 1 through 11 hours plus whatever the minutes are plus then AM. So that handles all of our different number formatting options, so that the time when it shows up on screen takes on a format that is familiar to us. You may look at that and go, really? I have to do that much crap to get my date and time to display correctly and properly in a form that I'm accustomed to? And the answer is, yeah. If you don't want to do that, you can go find where someone has written a little kind of JavaScript function that you can then load their script into your document, and then you would just plug in the time and it would spit it back with the kind of AM, PM and do it for you. But it would be doing this exact same logic behind the scene. And figuring out how to plot the sun onto this, you could come up with any algorithm of how to do it. You may decide that what I did you don't like and you come up with your own system. But what this does is this calculates sunrise, sunset, and divides that into a series of units, or a percentage of where are we in the time of day between sunrise and sunset, or sunset and sunrise. And then it plots according to that. So that's what we'll be looking at here. So inside the function plot, The beginning part here, it draws the background grid, so we're just going to leave that for now. And I'm going to then now, at this point, I'm going to calculate the time and sun position. So I'll be using the information from my weather object. So to start this out, I can simply const dt is going to be equal to my weather dot dt. Now that dt is that date and time. And the next thing I'm going to do is grab my sunrise, and that is going to be in my weather. And then I'm going to grab my sunset, and that is going to be in the weather as well. And then finally, I am going to log these out to prove that it's working. And I can log it out and say dt plus dt plus sunrise plus, oh, I forgot, sunrise plus, and then repeat for sunset plus sunset. So now what we need you to figure out is what is sunrise and what is sunset. With this we have current day and time, sunrise and sunset. So if I look at the values, current day and time, sunrise and sunset, these are all seconds that have happened since 1970. So I can see the current time, if we look at it where it ends in 0213, then we can see sunrise, or we'll go back even further, 312736, and then we can see then we will have 36 and then 5228. So we can see we're getting close to sunset looking at these two times. So we can see that between our date and time that the dt number is in between sunrise and sunset values. Now if you find that just looking at those numbers is a little bit hard to read it in that format, we could reformat those into human readable values. So if I were to, you don't need to add this to yours, this is just for explanation purposes, but if I look at it where we go sunrise date, sunset date, or sunrise, sunset, and then we take the actual time and put that into it, we can see now where we get there's sunrise, there's sunset, and we know that our actual time right now is at 1913. So it shows how we're getting close to sunset, but we're not quite there, grabbing our 1913 from up here. So if we format it into human readable time versus looking at it as seconds, that can make it a little bit easier to follow if that helps with your brain. But we don't really need that. That's not really important. So I'm just going to comment that out for now. That doesn't really factor into what we're doing. But what we do want to figure out is we want to find out, is it daytime? So I'm going to create a value and call it daytime. And I'm going to set it equal, well, if we leave it like this and just constant daytime, there's a shorthand way we can write this that I think does make sense, but I'm going to write it in longhand first. So we can say if sunrise is less than our current time and our current time is less than sunset, then we know that it must be daytime. because if daytime is greater than sunrise but is less than sunset, then we know it has to be daytime. And then we'll set daytime equal to true. Else daytime is equal to false. So we can write it out in this format as a way of saying if sunrise is less than day, our current date time, and our current date time is less than sunset, it must be daytime. But there is a shorter way we can write that out. And I'm just going to add it up to this line here. You can decide if it hurts your brain to go that way and you don't want to do it. And what we can do is we can say, we'll set daytime equal to, and now we're going to say sunrise is less than dt, and dt is less than sunset. So that's our conditional. We follow that with a question mark. And then if that conditional is true, we do our first thing, which is daytime will be equal to true. So we can just say true. Then we put a colon, and then we say false, which is if it's not true, if that conditional doesn't check out, then we grab false. So we can write it in one line. Now that's a lot of punctuation, and until you get used to it, that can be a really awkward way of working with things. But as you do get used to it, what you may find is it's nicer than having a whole bunch of curly braces with if-else statements. So if your if statement has two outcomes, in this case they're really short, true and false, then it's really easy to use it in this way. This particular way of doing if statements is called a ternary operator. So it's a conditional, and we write it out like this, where it's usually used when we're doing fairly simple kinds of conditional statements, and it allows us to just do something on one line. So it's an easy way of doing it, where we can say a condition, and then the condition when, or the expression that results when that condition is true, and the expression that happens when that condition is false. So that is a ternary operator. There's something that if you use them a lot, you start to really appreciate their conciseness. But if you don't use them a lot, it's hard to remember the syntax, and you have to go look up how to do it again if you can remember what it's called. That's the tricky part, is remembering that it's called a ternary operator. If you do, it's good. What I want to calculate now is I want to find out what percentage of the day or night is passed. So I want to figure out where does the current timestamp sit in relation to sunrise and sunset, or sunset and sunrise, because that gives me a percentage value, and I can use that to calculate position information of where to plot my sun or my moon onto my canvas, which is going to be where we want to move to next. So to do this, I can say if daytime, so if it's daytime, and we will be adding to this if it's daytime, if it's nighttime, because a lot of our animation things are dependent on is it day or night for what artwork we want to show. So if it's daytime or it's not, so we don't have to say else if. It's either going to be daytime or not. Oh, before I do that, I do need to set a variable. And I'm going to call this variable position percentage. So this determines what percent of the day is passed, and we're going to use that to set our position. When you're using a code editor that helps out with auto-completion, don't be afraid to use longer named variables, because it will help you have more readable code. Because if you just said called it P or something like that, you'd look in a later section of code, you'd be like, what is that? Because when your code editor helps autocomplete for you, then, because now I can start typing in, and I typed in PSIP, and it go, hey, do you want that? And I can just hit return, and now there it is. So I don't have to retype the whole thing. That speeds up my workflow and makes things a little bit better. So now this is where it's going to get a little bit fun. So we're going to set position percentage different whether it's day or night, because one is based on a percent of daytime, one is based on a percent of night. So we're going to have to calculate those two values out. So going to the daytime, we want to know where does our current timestamp sit as a percentage of the total amount of time between sunrise and sunset. So to do that, we can simply say if we take our current time, dt, and subtract from that sunrise, and then we'll divide that by sunset minus sunrise. So sunset, during the daytime, the sunset is later than sunrise, so it's a bigger number. So if we subtract sunset from sunrise, that gives us a positive value. That tells us how many seconds between sunrise and sunset occurred. Then we're going to take our current time, subtract the sunset or sunrise from it, so that now gives us how many seconds have happened since sunrise. So now we know how many seconds from when the sun came up have passed, how many seconds were available between sunset and sunrise, and then we want that to be a percentage. And that's going to then calculate where to plot our sun on our canvas. We'll do a very similar thing to nighttime. So it will be dt minus sunset divided by, and in this case, we start drawing on our canvas. We're going to be making a lot of references to the width of the canvas and the height of the canvas. And if I want to access it, I can just simply say, actually I do, yeah, I have the canvas. So we have the canvas object. We already grabbed the canvas object because we drew these boxes on it. We drew rectangles. You will notice the lines on it. I did rectangles. I did lines with a width of 1. And that's why it looks like there's lines, but they're actually rectangles. Because originally I was going to do it as like kind of a striped and then kind of a striped grid pattern, and then I gave up on or changed my mind on it. Because otherwise, if we add values to those, oh, 126. I can't use const here by not doing it as a ternary operator in one line. I can't create a variable and then change its value later if it's a constant, so now it has to be let. So you can see if I change it, instead of using 1 pixel rectangles, I did 10, and then that gives kind of a cool lattice pattern. All right. Because I originally had rectangles because it was going to be something different. But so we can create all kinds of cool patterns. But if we do it as the series of lines, the lines are going to help us plot what is happening with it. Now these divisions, I didn't go into them before. It's drawing the lines on the canvas. It's dividing it into 10 equal parts. That's why I take the width of the canvas divided by 10, the height of the canvas divided by 10, and then plot these lines onto it. And in doing so, we're able to then use that as a way to plot out the percentages and placement of our rectangle when we're going to put it onto the canvas. So I fixed the variable daytime there. It has to be a let. Now what we are going to do is the canvas width, I'll say is CW. So const CW is going to be equal to canvas.width, and const CH is going to be canvas.height. These are not mandatory variables, but the number of times we'll have to refer to the height and width of the canvas, I find it's just a whole lot easier just to save them and have a reference to them later. So that's why I choose to create these now. So putting those on screen, what I want to do is then put a rectangle on screen to represent my sun. I'm using a rectangle, not an ellipse or a circle, because that gives me very clear boundaries so I can see exactly where it's plotting itself on screen. Now, I'm going to make it the same height and width of the sun and moon images I'll use later, which is 100 pixels. So I know there will be an easy and direct translation with that. So with that, I'm going to say context, and I'm going to set the color for this object. And the color I'm going to use, I will just do RGB and 255, 255, 0. That will be yellow. And then context. And then I use fill rect. And to do this, I can just plot it anywhere I want on screen for now. So I could say 100. So it's X, Y, and then width and height. So we'll figure out better X and Y's in a moment, but the first step is to verify it is putting itself on the screen. And we can see it shows up, but not in the right color. And it didn't show up in the right color because I forgot to capitalize the S in style. It's lowercase fill, capital S, and then style. And now we get our box showing up at 100, 100. With our yellow sun box showing up on screen, it's time to figure out how to reposition it. So we're going to start out first and reposition its X position. So I can say let my sun, and I'm going to give it a destination value of dx, and I'm going to set that equal to my canvas width multiplied by my position percentage. Now, instead of drawing my rect at 100, I'm going to then change that to sun dx. So now when I save it and run, we'll see that it moves itself over. Now, if I want to test this a little bit more or have more control and not worry about what actual time of day is there, I can just set position percentage equal to something like 0, 1. So now if I do that, we'll see it's all the way over, and it lines up with the first grid line. Remember, I divided this canvas into 10 equal pieces. We can see it's lining up on that first line. If I put 3 in there, so 0.3, 1, 2, 3 lines over. So we can see how we're able to then control and see where it's lining up and how it's lining up and test that without having to worry about the actual time of day. When I want to use the time of day, I close that off, and then we can see now it moves it over to the side. So that now gives me that percentage value that I need. The next thing I want to do is to control the height. So this would be my sun dy. So d is going to be destination. We'll be using that destination value a little bit more when we start putting images on screen, because images, we will have a source X and Y and a destination X and Y. Source X and Y is where do we want to start copying pixels from in the image, and the destination is where do we want to draw those pixels on our canvas. So we have those two values. So we had the SX, SY, width and height, and then destination X and Y and destination width and height. So we have 8 values for every image that we draw on screen. That's why we're starting out first with something simple like a basic rectangle. So I'm first going to start out and say 0 for sun dy, and then change this in my fill rect to the sun dy, and load it, and we can see now it's the y is at the top. So our values for 0, 0 correspond to top left corner. So if I said my x was 0 as well, we'd see it draws it, x and y are 0, it draws it in the top left corner. So we always start counting from the top left corner. So it's similar to how we read a book. We start in the top left and work our way across and down. So that gives me an initial position, but that doesn't animate the height of the sun based on my time values. To do that, we have to do some conditional work to set it equal to some values. Now what I want to have happen is during the first half of day or night travel, I want the sun to start down at the bottom and work its way up. At midday or midnight, I want it to be at its peak, and then I want it to start going back down during the second half. So when position percentage is less than 0.5, we want our sun moon to go up. When it's greater than 0.5, we want the sun moon to start going down. So we can do that by saying if position percentage is less than 0.5, so that means we're on our way up, we now need to start boosting it up. So sun dy needs to be equal to something. Else sun dy needs to be equal to something else. So now we need to figure out what those else's are. So thinking about it, if I want to be down at the bottom, so at the beginning when position percentage is 0, so we're at the very beginning, I want to then position it, my box, so it's all the way down towards the bottom. So that would be the height of my canvas, CH, minus, now it's going to be minus my height of my canvas multiplied by this percent. So we're figuring out a percent of that value. So in this case, our canvas is 200. So if position percentage was 0.5, we would be at halfway, or 50%, 0.5 times that. So it should give us a value of 100, theoretically. So let's see what that does. Now, on the other hand, it would be if position percentage, if we start out at the top, we just want to now start increasing it by, so we say our height, and now we just can multiply that by, we have to figure out how much of our position percentage, and we'll figure that out. And the easiest way to do this is to just start putting in things like this, and let's see what we get using values that we can modify. So we'll start out and I'll say minus 0.1. Let's see what happens. So that should be this one. Now if I look here, I'm right here. unless you broke it, and then it doesn't work. Now if I save again, we went up 2 clicks. Now if I go to point 4, so it's 1, 2, 3, 4. We've gone up 4 lines. But we can see on the vertical axis, the sun is only kind of halfway up. So what we really have to do is we have to take this amount and double it. So there now, let's see, if we go 1, 2, 3, 4, 4 blue lines up, that corresponds to it. Now if I go back to 3, okay, we're at 3, 2, and 1. So 1, 2, 3, 4. So we can see it works its magic working its way across. Now 5, let's see where 5 gets us. 5 lined up on the X. But on the Y, I really wanted up at the top. But instead, 2, 3, 4, it's 5 boxes down. So we're off by 5 boxes, or 0.5. Whoop. Wrong button. But if we subtract here, now we're at the top. Now let's see where 6 brings us. Oh, that brought me down 1. Oh, wrong, 7. So 6 brought me down 1, 7 brought me down 2. I'm over 7 columns, but I'm only down 2 rows. Which tells me I need to do the same magic that I did here, the multiply by 2. And now it starts to line up. So the reason for drawing all those grid lines was to figure out, while animating the position of the sun, it helps me to see where things are lining up on screen. Adding images into the project is surprisingly straightforward and easy to do. The first thing I'm going to do is go grab my sky image. So to do that, I have to create an image object. So I'll say const, and this will be sky image is going to be equal to a new image. That's 2 words, new and then image. And a couple parentheses after that. I am putting all of the information for the images that I'm attaching to my file at the top. It's a good practice. When you start organizing your file, this is not when we're all done because of how we're piecing it together. It's not going to be a really super organized file, but it is useful to have certain things up at the top, like global variables or objects, like my images that I'm loading. I put those up at the top. So the first thing I'm going to do is make a reference to my sky image. Then I'm also going to make a reference to my sun image because I know I'll be loading that next. And I'll put that in there. Then what we have to do is set the source for these. So I can go sky image dot source src is going to be equal to, and now I list the file name. Now if I look through mine, my sky is called sky.png. And then my sun image is going to have a source of sun.png. You name yours, whatever your files are called, and it's all good. So I've created the image objects. I've set the source for those image objects. Now, one thing that we need to do is we need to make sure that these images are loaded before we try to use them. That's really, really important as we are working. So what we are going to do is keep track of how many images we're loading and how many images have been loaded. My image objects created, I have their sources set. Now what we need to do is set two more values here. One is going to be my image asset count. And in this case, I am loading, it's 2 images. And then I'm going to have, this time I'll use let because this is a value that changes. And this will be my images loaded. And initially it will have a value of 0. So
do you have to do that every time?
Image asset count is set. As I add more images, I'll update that value. Images loaded, that's always going to start at 0 because that gets increased in our image load handler that we'll be writing momentarily. So then I need to tell my sky image to add event listener. And the event I'm going to be listening for is the load event. And then I will call my image load handler. And we finish this with false, so the event doesn't bubble. That's our normal way of doing it. Now, we have to attach this to each image. So this is where copy paste is handy. Oh wait, I only have 2 images so far, my bad. Later on we'll have more. And the next thing that we do is define our function image load handler. And inside of image load handler, it's going to say images loaded plus plus. Then it's going to check to see have we loaded all of our images. And we'll say if images loaded is equal to 3 equal signs, image asset count, at that point, then we want to contact the weather server, open weather map, and grab the JSON, which is then, once the JSON is loaded, is going to then call our function to draw everything on screen. So we sequence it. So when one function finishes, then it calls the next one. That's how we prevent the JavaScript from trying to use things before they're ready, before it has access to them. So this is where we'll call hxr send, and then we comment out or delete the previous version of it. So I comment out the one that we had before, and now in our image load handler it says if we have loaded all of the images, so images loaded is equal to image asset count, then it calls hxr send. All right, so we have the source x and y, source width and height. So this is where I'm copying the pixels from in my image. And then I specify the destination values of where I want to start drawing it on screen and how big I want to draw it on screen. So which image, and then 8 numbers. Source x, source y, source width, source height, and then destination x, destination y, destination width, destination height. So when I do that, and look at it, it then draws my background on screen. After drawing the sky on the screen, one in is going to be similar. I am going to comment out the previous sun that I drew, but we will be doing something similar to that. Now what I want to do is this exact same thing of context, draw image, and Got to use parentheses, not curly braces. Now the image I'm drawing this time will be my sun image. And I'm going to draw it. Its source will be 0, 0, and my sun is 100 by 100. I know that because I made it. Yours will be whatever size you made yours. And then I will be positioning this sun on screen at my sun dx, sun dy, and then once again I will continue with the 100 by 100.
Question. Why did you put it that far down?
Sun is being drawn down here because I'm going to put a few comments in to help make sense. This will be draw the sky. Then we see the next chunk of code is related to the sun because we are now calculating the dx and the dy and the sun's dx and dy related to position percentage. So then it makes sense to draw the sun after that. Otherwise, I won't have access to dx and dy for the sun, and I won't be able to draw my sun on screen. Now, currently, I'm drawing the sun only, and I'm drawing the sky. Now, I want to modify. Now, my sky, as I set it up in this particular project, my sky is set up where it has both day and night in one giant image. So I can just slide that image over based on whether it's day or nighttime. I could swap which image I'm going to use, like what we will do on the sun and moon. So we'll use one object, but then change out which image we're using for that item. And that is another way of doing it. So we're going to kind of explore two ways of pulling this off, whether we're at daytime or nighttime. And we'll look at that now. So to do that, I also will need to load a moon image. So I have my sun image, and now I'm going to just create a moon image because my moon is a separate file. So now I load my moon image and change my total image asset count up to 3 because I'm loading 3 images. And then we have to tell the moon image to listen for the load event and call the image load handler method. To adjust my image for the sky based on daytime and nighttime, what I want to do is to create a variable. So after I set daytime, but before I actually calculate its value based on sunrise and sunset and the current time, what I want to do is create 2 more values that we're going to need. And one will be the x value that I need for the sky. The other is going to be a value to hold my whether we want to use our sun or moon, because we need to be able to set which image we're assigning to sun moon, and sky x is going to be adjusted because my sky image is one giant long image. So if it's daytime, sky x is going to be equal to 0. But if it is nighttime, sky x is going to be equal to 900, or half of the image. Now, what we also want to do is, if it is nighttime, I want to set my sun moon, well, no, sorry, if it's daytime, I want to set it equal to my sun image. And if it is nighttime, we'll set sun moon equal to moon image. By adding these additional values in, when we draw the sun, the sky, we now set its x equal to sky x. And then when we draw the sun, we'll just set it equal to sun or moon, instead of drawing the sun image or the moon image. So we just are drawing one object. We just change which object we are drawing here, based on what we've put into our, is it daytime or is it nighttime in our project.